This is a complete walkthrough of the matching activity. Question 1. Evaluate the expression cosine of negative 90 degrees. Hint, sketch a picture. So to find the cosine, I'm going to be working with the trig ratios, which would make the x over the r is what I'm looking for. If you don't remember the trig ratios, you can look that up in section 1.3. That's in day 1. And you'll see those trig ratios are listed there. Okay, so I'm trying to graph negative 90 degrees. But negative 90 would be something that we would have to graph in reverse order. So what you can do is find an angle that's coterminal by adding 360 degrees. That means you're going to graph a 270 degree angle. Start here at the initial side and rotate around until you reach 270. This is 90, 180, 270 would be right down here. Okay, now the problem with this angle, trying to find our x and r, is that this is not a triangle. So even if I was to put a point here and drop a perpendicular, this is not a triangle. So in these problems, which were sitting on the quadrant angles like 90, 180, 270, 360, you had to assume the r was equal to 1. And that's the way that the book set these problems up. So you let the r equal 1. If that's the case, then what you can do is name this point using the fact that this is 1 unit out. So this point goes over none, and it's down 1 unit. So this would be 0, negative 1. And you can label this x and y. So then x equals 0, y equals negative 1, and you have your x and y and r value. So 0 divided by r, which is 1, 0 divided by 1 equals 0. So the cosine is 0. And you can check it on the answer page. It's right here, 0. Question 2 is talking about using the appropriate identity to find the function value. Round to 3 decimal places if needed. Well, this one's a fraction, so we're going to give the answer as a fraction. We're trying to find the cosine of theta given the secant of theta equals negative 5 over 2. So this is the given. These were questions from section 1.3, and what we're doing is using those reciprocal identities. So I'm trying to find the cosine of theta, and I'm going to replace it with one of the reciprocals. So these were in section 1.4, the reciprocal identities. So what I can do is I can either look in the notebook or I can go ahead and flip to that section, and here they are in this second page right here. Okay, so I'm looking at the one that says cosine theta equals, and I'm going to write down 1 divided by the secant of theta. These are the questions where I take the given information, secant of theta equals negative 5 over 2, and I'm going to plug that in, this negative 5 over 2, in place of the secant. So I took out the secant, and I'm going to put in the negative 5 over 2. This is one of those questions where you're taking a number and trying to divide by a fraction. So you're going to keep the top and flip the bottom. You're multiplying by the reciprocal. Keep the top, flip the denominator at the bottom. So instead of negative 5 over 2, it's negative 2 over 5. And instead of dividing, I'm going to multiply by that reciprocal. Okay, 1 times negative 2/5 is negative 2/5. I can check my answer on the answer sheet. Here it is. Here's a negative 2/5, so it checks out. Question 3, determine the signs of the given trig functions. And this isn't SINE, this is like positive and negative. So we're determining the positive or negative signs of the given trig functions of an angle in standard position, cotangent of negative 200, and secant of negative 200. So the hint is to sketch a picture. So I'm going to draw out an x and y axis. I need to draw an angle that is coterminal to negative 200. So I'm going to add 360. So what I'm actually doing then is I'm going to draw a 160 degree angle because I need to draw something that's positive. Starts here, rotates around. This is 90. If you go all the way over to this line here, it would be 180. So somewhere here in this quadrant. What's important is that you know what quadrant your angle is sitting in. And in this case, you can see that this angle will be in quadrant 2. So we're working with quadrant 2. Okay, so what we need to do is figure out what do you know about the cotangent and the secant in quadrant 2. So I'm going to look this up in the book in section 1.4, which is actually page 30, and it's in section 1.4. Okay, so I'm going to take a look at it, and I need to figure out what cotangent and secant are in relation to quadrant 2. So here's my chart. This again is page 30. This is section 1.4. So here's cotangent. Cotangent, if you look at quadrant 2, the cotangent is negative. And in quadrant 2, the secant, the secant is also negative. So in quadrant 2, the cotangent and the secant are both negative. Okay, so what are the signs of these trig functions? Cotangent, secant, they're both negative, and let's look that up on our answer key just to make sure that's an option. So we're looking for a negative and a negative. Here it is, negative, negative. So that one checks out as well. Identify the quadrant for the angle theta satisfying the following conditions. The cosecant of theta is greater than 0. That means it's positive. And the cotangent of theta greater than 0, that's positive. So what we're looking for is a quadrant where the cosecant is positive and the cotangent is positive. So let's look that up on the chart. Again, we're going to go back to that page 30, and we're looking in section 1.4. So first I'm going to figure out where the cosecant is positive, and I'm going to list those quadrants. So let's look at cosecant. Here we go, cosecant. And we're going to list the quadrants where the cosecant is positive. That would be quadrants 1 and quadrant 2. Next, we're looking for where the cotangent is positive. Cotangent would be quadrant 1 and quadrant 3. I'm looking for what satisfies both conditions, and that would be quadrant 1. And you can see quadrant 1 checks out. Question 5 is the same type of problem. I'm identifying the quadrant for the angle satisfying the conditions. So I can go ahead and kind of separate it out. Secant of theta is less than 0. That means negative. And the cosecant of theta less than 0. That means we're looking for negative. So I'm going to go back to that chart in section 1.4. And again, this is on page 30 in section 1.4. And I'm looking up. First, I'm going to look for the secant where that's negative. So let's take a look at that one. Here's secant. Here's negative. That would be quadrants 2 and 3. And now I'm going to look for where the cosecant is negative. Cosecant, here's cosecant. Negative would be 3 and 4. So it satisfies the condition in quadrant 3. And again, we can check our answer by looking at the answer sheet that's provided. And that would be, let's see, we've got quadrant 3. Oh, here it is up here. So it checks out. So this question says to sketch an angle in standard position such that theta has a least positive measure, and at the given point is on the terminal side of theta. So I'm going to start by sketching out the angle. So here's your starting side. The initial side is over here. I'm going to draw the point 3, -7, which go over 3 to the right and down 7 approximately. So again, +3, -7 would be down here. So this angle is going to begin here at this initial side. rotate around counterclockwise, and it will end down here at this point. When we did these, what we did was we dropped that perpendicular, and you always go towards the x-axis. Go ahead and label your sides. Find the x-axis, that's going to be x. Label your hypotenuse, and remember you always use the letter r. And then the other side, which is parallel to the y-axis, is y. Okay, so we have the x and the y here. So after looking at this question again, sketching an angle in standard position such that theta has least positive measure, it doesn't actually ask us to find any other information. It's just asking you to sketch this angle. So really, we don't even need this part over here. So I can just leave it as the angle itself. So I can kind of get rid of this part. If you have it, that's fine. And what I'm looking for is just this angle here. So let's take a look at the answer key. And we'll see which angle is sketched down here in this quadrant 4 and has a rotation around like this. So let's take a look at the answer key. There are two angles that are sketched out here. This one started here and rotated around. This one started here and rotated around, and that's the one that we're looking for. Now, we dropped the perpendicular and stuff, but we didn't have to actually do that. This question was just asking you to sketch the angle. So the answer for this one is this is it right here, and this matches with what we've got now on our sheet. Okay, this is like the last one where it says sketch an angle in standard position such that theta has a least positive measure and the given point is on the terminal side. So we're not actually going to be solving anything, just like in the last one, and this time I won't go too far. This time we're just sketching out that angle. So go ahead and draw your x and y axis. Draw your initial side and rotate around counterclockwise until you get to the point -3, 0. So this is an angle that makes a line. This is our theta, the rotation right here. And what we're going to do is match this up with our answer key. So again, we're just sketching the angle. It doesn't say anything about finding any trig function values or anything like that. Sketch the angle. So that would match this only other one that's sketched. So that would be this one here. So far I drew out the x and y axis. I drew the point -4, 3. This angle is going to start here at this initial side, rotate around counterclockwise, and it will pass through that point. Now this one I am finding the sine of theta. So unlike the last two examples, I do need to go ahead and drop that perpendicular. So if I was just drawing the angle, I could stop. But this one I need to go ahead and make the triangle. So this side we're going to label x. You've got your hypotenuse, which is r, and this would be side y. Okay, so these are your x and y values. X is -4. You've moved -4 to the left, 4 to the left, and y is -3. You've moved 3 units down. To find the hypotenuse, the r, you're just going to use the Pythagorean theorem. So I plugged in the x squared, -4 squared is 16, the -3 squared is 9, 16 plus 9 is 25, and so r equals 5. Remember, this question was ultimately asking you to find the sine of theta. The sine can be found in section 1.3. The sine is the y over the r. So in this case, it is -3 over 5. And again, you can always check this on the answer key over here. And here it is right there, -3 over 5. So in this question, we were trying to decide if something's positive and negative, and what you did was start by drawing a sketch. So this angle needs to be drawn in quadrant 4. So I sketched out an x and y axis. I've got the quadrants listed, and I'm going to put a point somewhere down here in quadrant 4. Okay, the angle always starts over here at this initial side, rotates counterclockwise, and it's going to pass through this point that I put here in quadrant 4. Okay, so I need to decide if it's positive or negative, and so I'm going to go ahead and drop the perpendicular. If I was just drawing the angle, I wouldn't need this step, but I do need to decide if the ratio of the y over the r is going to be positive or negative. Okay, so let's take a look at this. This is side x. Remember, on the x-axis, your hypotenuse is always labeled r, and then the other side would be y, and it's the one parallel to the y-axis. We need to figure out if these are positive or negative. R is always positive. Remember, R is always positive regardless of where it's sitting. But the y, since it's moving in the negative direction from the x-axis down to this point, this would be negative. So negative divided by positive is negative. So the ratio is going to be negative, and let's check it on our answer sheet. And we do have an answer of negative right here. For this question, I need to look at section 1.3, which is page 25, and I'm going to look at this chart right here to determine these trig values. So I'm evaluating sine squared 180 plus cosine squared 180. If you remember from when we did these, this means that I take the sine of 180 and I'm going to square it, and the cosine of 180 and I'm going to square it. That's the 2 here and the 2 here. So I'm going to find these values on that chart and I'm going to plug them in. Let's start with the sine at 180. So here's sine, here's 180. Those two things meet here at 0. So the sine of 180 is 0. Next, I'm going to look up the cosine at 180. Here's cosine, here's 180. And the value is, as you can see, negative 1. Go ahead and solve it. 0 squared is 0. Negative 1 times negative 1 is 1. So 0 plus 1 is 1. I'm going to look that up on my chart. I should find a positive 1 on my answer sheet. And here it is. So this time I'm evaluating the cotangent of 180. And again, it says sketch the picture. So I went ahead and drew out the x and y axis, and I'm going to draw an angle in standard position. Starts here, rotates around counterclockwise. 90, 180 means it's going to be this line. So this is my 180 degree angle. Okay, so I'm looking for the cotangent of 180. The cotangent, if you look in section 1.3, you'll see the trig ratios. It was from day 1 notes. And these trig ratios for the cotangent will be the x and the r, or x over y. Cotangent, sorry, is x over y. So what I need is both of these values. In order to find them, I need to have a point somewhere on this graph. So when you have a special quadrant angle at 0, 90, 180, 270, or 360, and there's no other information, you can always assume that you have a point 1 unit out. And we did this the same way on that other example. So this would be 1 unit out. The r equals 1. The length of this segment here is 1. And so all we need to do is name this point. In order to get to this point, we went 1 to the left, which means negative 1, and you don't go up or down, or so 0. So that means this point can be labeled x and y. So that gives us our x, and it also gives us the y. All right, so now all I need to do is set up the values. The cotangent is the x over the y. Well, x is negative 1, and y is 0. So your cotangent is going to end up being undefined. So the cotangent at 180 is going to be undefined. Anything divided by 0 is undefined. And we can check it over here. So if you go to your answer sheet, there is definitely an answer that's undefined. A pulley rotates 400 times per minute. Through how many degrees does a point on the edge of the wheel move in 1/4 of a second, or 1/4 of a second? So I'm going to start by taking the 400 times per minute. This is like 400 rotations per minute. We did some of these almost identical to this in the review. And I want to figure out how many degrees is it going through. Well, first of all, let's go ahead and think about how many degrees are in a full rotation. So if you think of a circle, you've got 360 degrees. So every time I rotate around once, I'm going 360. So you can add 360, 360, 360, 360, or you could just multiply right away by 360 degrees. So this tells us there are 144,000 degrees in each minute. The question, though, is asking for seconds. So let's start by getting rid of minutes, and we'll replace it with seconds. So I'm going to take that and divide by the 60, and I got 2,400 degrees per second. This question, though, is not asking for a full second. It says what happens in a quarter of a second. So you can multiply by 0.25 or you can multiply it by a fourth. Either way will give us the answer. Okay, so the seconds will divide out. You're going to multiply the 2,400 times 1 and divide by 4. Or you could just multiply by 0.25 to the 2,400. So I'm going to divide it by 4, and I get 600 degrees. Again, you can come over here and check your answer, and you'll see that there is your 600. This question is asking you to find complementary angles with these two given measures. So remember, complementary means they add up to, complementary would be 90. So I just set them equal to each other, and I'm going to solve. So 5 plus 2 is 7x. I bring down the minus 1. I'm going to add 1 to both sides. Divide by 7, and x equals 13. So then I'm plugging it back in here. 5 times 13 is 65, minus 1 is 64, and 2 times 13 is 26. If you add those together, you end up with 90 degrees. For number 14, you're going to use page 25 again, which is on section 1.3. 5 times the sine squared of 90 plus 2 times the cosine squared of 270 minus tangent of 360. So remember, I'm taking the sine of 90 and I'm squaring it. I'm taking the cosine of 270 and I'm squaring it. And then I'm going to just write in the tangent of 360. I'm using this chart over here. The sine of 90 is 1. So I'm going to plug in that value. And I'm going to go ahead and multiply those in. I need to look up the cosine at 270. Cosine of 270 is 0. And then finally, the tangent at 360. Here's tangent, here's 360. Again, it's 0. Remember, you need to square before you multiply or add. So 1 times 1 is 1. 1 times 5 is 5. 2 times 0 is 0. And then minus 0. So my answer is 5. Remember, you can check your answers by looking at the answer sheet over here. And here there is an answer of 5. Okay, suppose theta is in standard position. We're going to give the exact value for the indicated trig function. We're looking for the sine of theta. Remember, the sine is the y over the r. So we do need to draw the triangle as we're drawing this picture. So I'm going to draw my angle. And it says this time at the point 0, -2. So 0, -2 means I'm going over none and then down 2 units. So this would be 0, -2. I'm going to draw my angle through that. So that means I rotate around. And unfortunately, I cannot drop the perpendicular. But what I can do is see that I have an x and a y that's given. So this is my point here. I don't have to worry about a triangle. X is 0, y is -2, and I can still find the r by doing the Pythagorean theorem. So 0 squared plus -2 squared, and then I'm going to take the square root of whatever I get here. This is 0, this is 4, so we're taking the square root of 4 which is 2. So r equals 2. Okay, so the sign is the y over the r. Negative 2 over 2, so sine of this angle is negative 1. And you can go over and check your answer, see if there is a negative 1, and there it is up in that corner there. Use the appropriate identity to find the function value, rounded to 3 decimal places if needed. Okay, so this one is a decimal. We did one earlier that was a fraction. We're looking for the sine of theta, that's what we're trying to find, given the cosecant. So I'm looking for sine of theta given the cosecant. So I'm going to page 29, which is in section 1.4, and I'm looking for the trig function that says sine theta equals. These are those reciprocal identities, and the sine of theta is equal to 1 over the cosecant. Of theta. Well, the cosecant of theta is given, so what I'm going to do is cross that out, and I'm going to replace it with the value. If it's a decimal answer, you can just give your answer as a decimal as it states in the... Okay, now my calculator reads 0.70067 and so on. But the directions say to 3 decimal places if needed. So that means I'm going to round to the tens, hundredths, thousandths place, and you need to consider that this is a 6, so you're going to have to round this up. So instead of 700, you're going to round it to 0.701. That 6 is going to round that up. So the sine of theta equals 0.701. And I can check that again over on my answer sheet. And let's see, it's right here. So that one works out.